A very good morning to one all present here. Today I, Ananya, along with my teammates Ariv, Harshit and Kritika, am here to present before you a very detailed explanation of the surface area of four very important 3D figures, which are cuboid, cube, cylinder and cone. And we hope you like the explanation and this presentation. Now we will study about the total surface and the curved surface area of a cube. As we know, a cube is made up of squares stacked together. And we already have learned that a square has all equal sides and the area of a square is nothing but side to side, or s square. Now when we come to the total surface area of a cube, we do nothing but simply multiply 6 with s square. Why so? Because the cube has 6 faces. Total number of faces in a cube is 6 and area of each of these faces is a square. Simply the area of the entire cube will be nothing but 6a square. What is next? The curved surface area of a cube. Supposingly, if you remove the top and the bottom surfaces from a cube, you will be left with what is called 4 surfaces. These 4 surfaces are also given a very special name, and that is the lateral surfaces of a cube. As we can already now connect that the lateral surface area of a cube is nothing but the area of these 4 faces. So the area of 6 faces, which was the total surface area, was 6a square, and the area of 4 faces, which will be nothing but 4a square. Why? Because these 4 faces are equal squares with equal sides, and we multiplied 4 with the area of any one of these faces, which turns out to be 4a square. So the curved surface area of a cube is 4a square. Now we conclude that the total surface area of a cube is 6a square because of 6 faces, and the lateral surface area of a cube is 4a square because we knock off the top and the bottom faces and are left with only 4 faces. Thank you.
Next up, we'll talk about the TSA and CSA of a 3D figure commonly known as the cuboid. So as we all already know, a cuboid is nothing but a cube with rectangle faces instead of square. So first of all, let's begin with the area of a rectangle. The area of a rectangle is nothing but the product of its adjacent sides. And a cuboid, being a 3D figure, has 3 different sets of sides, commonly known as the length, the breadth and the height. So now let's begin by deriving the formula of the TSA, which is nothing but the total surface area of a cuboid. So when we talk about the total surface area of the cuboid, we begin by the top and the bottom face, which are obviously 2 identical rectangles. The area of these 2 rectangles is length into breadth, and we'll multiply this by 2 because they come in a pair. Great. So next we'll talk about the 2 opposite equal pairs of rectangles joining the top and the bottom rectangle in a cuboid. So one of the pairs out of these 2 pairs will have their area as 2LH. We multiplied by 2 because they come in a pair, and the other pair will have the area as 2BH, which is breadth into height, and we multiply this by 2 again because it is a pair. So let's start forming the equation. So now we'll begin by the area of the top and the bottom rectangle, which is 2LB, which is nothing but 2 into length into breadth, plus 2BH plus 2LH, which is the area of the 2 opposite identical pairs of rectangles which join the top and the bottom rectangle. Great. So now we have our equation. 2LB plus 2LH plus 2BH, and as we all already know, we can take out the common 2 from this equation and put it outside. So now the final formula for the TSA of a cuboid is 2 in brackets LB plus BH plus LH. So now we'll talk about the CSA, which is nothing but the curved surface area of a cuboid. As you all already know, in the curved surface area, we don't add up the areas of the top and the bottom faces of a 3D figure. So now we'll go back to the previous equation, which was 2LB plus 2LH plus 2BH. Good for us, we already know what was the area of the top and the bottom figure summed up, which was 2LB, 2 length into breadth. So now we'll pick that out of the equation, and what we are left with is 2LH plus 2BH, which is nothing but the area of the two opposite equal pairs of rectangles joining the top in the bottom rectangle. So we already have our formula 2LH plus 2BH. Now in this equation, unlike the previous equation, we have two things in common in both the terms, which is 2H, the 2 and the height. Great, so we'll pick out both of those things and put them out of the bracket. So now the final formula of the CSA of a cuboid will be 2h, 2 into height into inside brackets, length into breadth, L into B. Great.
Now let's take a look into the cylinder. So if we take a number of circular sheets and stack them up, the figure that will be formed, that will be known as a cylinder. If we stack them up vertically, that will be known as a right circular cylinder. Now if we take a closer look into the cylinder, we could see that it is made up of one rectangle and two circles. The center portion of the cylinder is made up of a rectangle, and the base and the top is made up of two circles. Now coming upon the CSA, or the curved surface area of a cylinder, the curved surface area excludes the two circles and only includes the center portion, that is a rectangle. The rectangle was previously a circle, so the circumference of a circle is 2 pi r. And then when we multiply it by the height of the cylinder, we get the curved surface area, that is 2 pi r h. Now coming upon the total surface area, or the TSA, of a cylinder, it is we have to include the two circles now, as we excluded it in the CSA, in the curved surface area. So when we included, the area of the circle is pi r square. So there are two circles that would add up to 2 pi r square. Now when we add the CSA, that is the center portion, with the top and the base, that adds up to TSA, that is 2 pi r h plus 2 pi r square. That adds up to 2 pi r plus h.
So now I will tell you the TSA and CSA of a cone. So as you know that the base of a cone is circular in shape. So what's the area of a circle? It's pi r square. So we'll leave this part right here and we'll now move on to the CSA part. So first of all, you all know that cone is made up of a circle. So when we make a cone from a circular sheet, its radius is called as L. The circle's radius is called as L, which means the slant height of a cone. When we can see that the circle is made up of many triangles, and the area of a triangle is half into base into height. So you all know that a circle is basically made up of many triangles joined to each other, and the area of a triangle is half into base into height. So the height will be represented here by L, which means the slant height, as I told you. So let the base of triangle be represented by alphabet B. So when we add the base of all the triangles of a circle, we will get the sum which will be equal to the circumference of the circle. The circumference of the circle is 2 pi r. So the equation that we will get for the CSA of the cone will be half into L into 2 pi r. So after further solving it, we will get the equation and the final CSA of the cone, which will be pi r L. Next we move on to the TSA of the cone. So TSA of the cone will be the addition or the sum of the bottom and the CSA. So the CSA we got it as pi r L, and the bottom is a circle and the area of the circle is pi r square. So after further solving this equation, we will get the TSA of the cone, which will be pi r into r plus L. This is all for cone, and thank you.
The first figure here is a gift box. A gift box, as you may be familiar with, is in the form of a cube. Now why is it so? That is because a cube with all equal sides gives a perfect base or foundation for you to put in whatever pictures or things or gifts you want to put inside one box for your loved ones. Also, it makes a perfect surprise and a very maintained figure to give to someone.
The next figure that we see is that of a smartphone. A smartphone is mostly in the shape of a cuboid. The reason that it is a cuboid is that a cuboid provides a perfectly flat surface to provide a good enlarged screen along with edges that can be made as thin as possible according to the user's need.
The third figure that you can see is of a cell. Cell is basically a cylinder. It is a cylinder because cylinder is a very compatible figure. It is very easy to handle and it is easy to be inserted and to be taken out. The fourth figure that we can see is of a cone. It is basically the cap of a garden gnome. The cap of the garden gnome is really pointed. It is because it prevents birds from sitting on it and also humans to step on it.
A mandala is a complex, abstract design that is usually circular in form. In fact, mandala is a Sanskrit word which means circle. Mandalas generally have one identifiable center point from which emanates an array of shapes. In this figure, we have used many solid shapes such as circles, cones, triangles, cylinders, cuboids, of which we can find the surface areas. Mandalas can contain both geometric and organic forms. They can also contain recognizable images that carry meaning for the person who is creating it. In essence, mandalas represent the connection between our inner worlds and outer reality.